Okay, so solving and there's a bunch of different ways to solve quadratics. Like I said, I'm going to hit sort of the big ones, and even with factoring, there are different methods to factoring than what I'm going to show you. There's the box method. There are other types of method out there. And if you have a different method for factoring quadratics than I'm going over, then feel free to use your method as long as you get to the right answer at the end. All right, so first we're going to talk about solving by factoring. All right, factoring is based on the fact that we have the zero product property. Product means multiplication, right, which means I need to get a multiple, and that's what factoring is. It's undoing a product so I can see all my factors. 12 factors into the product 2 times 6. 2 and 6 would be factors of 12. And so when we're factoring a quadratic, that's what we're doing. We're undoing the multiplication part so that I could see what did I multiply together to get me my quadratic. Because I want to get down to a product, a multiplication, so that I can use a zero product property. The zero product means if I have two things that are multiplied together and it's equal to 0, which is why we always set the quadratics equal to 0 when we go to solve them, one of those values have to be 0 or both of them have to be 0. So the answer is either A is 0 or B is 0 or both of them could be 0. And that's how we solve quadratics using the zero product property. Now notice it only works if it's set equal to 0. If it's not set equal to 0, so this note is here, if it's not set equal to 0, it's not the zero product property. It's the only property that works this way. If it's set equal to some other number, any other number, it's not true. Right? And a simple example would be, suppose I had A times B equals 1. That doesn't imply that either A equals 1 or B equals 1 because that's not true. Right? That might be true, but I can have A be M over N and B be N over M, the reciprocal. And when I take the reciprocal, and those could be any numbers like 50 over 10, 10 over 50, and I multiply them out, I get 1. There are infinitely many different answers that they could be than 1. And so, and 1 is the easiest case, again, that would work for any number. And so the zero product property, keyword 0, only works for the set. 0 is sort of a special number, only works for that special number. An equation equal to any other number, this doesn't work for. Right? Only works for 0. And so when we factor, that's why we can factor and solve this way, we always have the factors set equal to 0. Right, so first step is to always set your quadratic equal to 0, because that's the only way this works. So you can't have your quadratic set to equal any other value. It has to be set equal to 0. So you move all of the terms to one side, set it equal to 0, and solve the equation for the 0. When we're factoring, there's two cases. There's the easy case and the hard case. So we're going to start with the easy case. Alright, the easy case is when the first value is 1. A is 1. Alright, so that A term here at the beginning is 1, and I still have a B term and a C term. And what makes it the easy case is because we're going to get two binomials out. The only way to get x squared is an x times an x. So I know when I get my binomials out, the very first pieces have to be x. And then I just have to figure out, well, what's the rest of it? Well, I do that by using the middle term, the b term, and the c term. Alright, so my first example is x squared minus 4x minus 12. It's the easy case, so I know it's going to factor into x something times x something. And I figure out what those somethings. I use the 4 and the 12, and again I use the negative because it's negative 4, negative 12 to do that. And what I do is I figure out what are factors of 12. So what factors means multiply. What do I multiply to get 12? That when I add them up, I'm going to get the negative 4 in the middle. Alright, well, 2 times negative 6 gives me my negative 12. 2 plus a negative 6 gives me my negative 4. And so 2 and negative 6 are the answer. And so this factors into x plus 2 times x minus 6. That equals 0. Again, you can check your answer. If you're not sure, do the multiplication of the middle terms and the outside terms. So I check the middle terms and the outside term. The middle term is 2x. The outside term is x times negative 6, so that would be negative 6x. When I add those up, I get the negative 4x in the middle. If I don't get that middle term, then I've not set it up correctly. And now I've got my product rule. I've got, this would represent A, and this would represent B equals 0. So A is the 2x, x plus 2, times B, which is the x minus 6, which means one of those two or both of them give me out a 0. And so that's what we do. X plus 2 gives me out a 0, or x minus 6 gives me out a 0, and I solve those. And so one of my answers is a negative 2, and one of my, so this is a 2 case, right? That means it crosses the axes twice. So negative 2 is a solution, and 6 is a solution. I'm going to do one more of those easy cases. And again, factoring, this should be something you've seen multiple times before. Alright, so next example. Again, it's an easy case because I've got the x squared, which has got the 1 in front of it. And so I look at the 24 and the negative 11. I need factors of 24 that when I add them together, I get negative 11. So factors means multiply, right? What do I multiply to get 24? And I add, it comes out negative. And first of all, 24 is a positive number. 11 is a negative number, so that means when I multiplied, they both had to be negative, right? In order to add them up and get a negative number, multiply and get them a positive number. And so this tells me that they're both negative. And so if I have negative 8 and negative 3, right, that is positive 24, right? Those are the factors. And then if I take negative 8 and add to it negative 3, that'll give me out negative 11. And so negative 8 and negative 3 are my values. And so this factors into x minus 8 times x minus 3 set equal to 0, because now I use the 0, that set equal to 0 is important, because it only works if it's set equal to 0. And now I have my two factors where x minus 8 can give me out a 0, or x minus 3 can give me out a 0. So 8 is a solution, and 3 is a solution. So again, this would be a graph that would cross it twice, once at 8 and once at negative 3. Alright, so that's the easy case. And you can always check your numbers again, like I did before. You can check the middle numbers and the outside numbers. If I get negative 8x and I add a negative 3x, well, that's going to add up to my negative 11. Alright, now the hard case. The hard case, there are, like I said, a bunch of methods out there for the hard case. I'm going to talk about the most common methods that we use, which are the guess check method and the grouping AC method. If you have a box, I know box method is one that's very popular right now. If you know the box method and you want to use the box method, that's fine. Alright, the first one I'm going to talk about is the guess check method. Alright, the guess check method is one where it kind of utilizes a little bit what I did in the last, with just slightly more complex. And the guess check works the best if the number in front of the x squared term is prime. Right, so it has to do with this first number here. Right, that's prime. Prime means I can only multiply it in itself in 1. That's the only way it breaks down. And so my example here would be 2x squared minus 13x plus 15. 2 is prime, meaning the factors of 2 are 2 and 1, and that's it. And so that tells me that the only way to split this x squared term up is 2x times x, right? 2x times x will give me my 2x squared term. And then I have to fill the missing pieces, right? What are the other parts of my factors? Right, well, this is where it kind of goes hand in hand a little bit with what we did in the last section. It has to do with the 13 and the 15, right? And I'm going to kind of figure out that both my answers have to be negative because 15 is positive, but the middle term is negative. So since the constant term is positive, both terms have to have like terms, right? The 15 is positive. And since the middle term is negative, they both must be negative, right? That's the only way I can get the positive 15 is if I had two negative numbers and I multiplied them to get 15, and then I added them and I got negative 13. Right, and that's sort of what we're going to do. And so the guess check method, well, we're still going to look at these. We're going to guess with 15. What are the factors of 15? When I do my multiplication, it's got to add up to negative 13. When I do that sort of check my outside terms and my middle terms, it's got to add up to 15, or 13. Negative 13. Alright, so I mentally, and so I did a physical lift, but you can also do this mentally. The possible factors of the first term and the last term, alright, for each binomial case. And so I've already got the first term as x times 2x, and so then I've got to split 15 up. I know 15's got to be split up into a negative. So 15, one way to split it up is negative 15 times negative 1 gives me out my 15. And then I check my middle terms to see if I get that negative 13 in the middle. Alright, so again, I check my inner and outer. So my inner here would give me a negative x. My outer would give me a negative 30, right? That's where these numbers are coming from. Well, that adds up to negative 31. Well, that's not the middle term. I need a negative 13x, right? And so that doesn't work, so that's not correct. Then I split it up. Well, 15, what if I flipped it around? Put the 15 with the 2 and put the 1 with the x term. Check my middle term, so that middle term would give me out my negative 15. This term would give me out my negative 2. That gives me out negative 17, which again is still not what I want, so that's wrong. Well, the next thing I can look at is 5 and 3, right? 5 and 3, when I multiply 5 by 3, I get 15. I have to have negatives, negative 5 times negative 3, and then I check my middle terms. Alright, well, this middle term is going to give me my negative 3. This middle term is going to give me my negative 10. Negative 10 plus negative 3 adds up to the negative 13x. And so there's my check. So this is the correct binomial multiplication. It's the correct factor. So factors into 2x minus 3 times x minus 5. Alright, now I can solve it. So my 2x minus 3 equals 0, and my x minus 5 equals 0. And so I move that 3 over and then divide by 2. And so one of my answers is positive 3 halves. And my second answer is positive 5. So 5 and 3 halves are the solution to my original equation. Alright, and that's the guess check method that I typically use if I'm doing this, because again I've done a bunch of these and that's sort of the method that I use. Again, if you use the guess check method, you can, you don't have to. An alternative is what's called the ACR grouping method. This is also similar to what the box method is, so if you are one of those who use the box method, you're doing this, you're just organizing your information in a box, but basically this is what you're kind of doing. Alright, so for example, I've got the function 6x squared minus 11x plus 35, and so since the 6 isn't prime, I wouldn't use my guess check method, I would use the AC method. And so what the AC method means is what you do is, well, that's what you start off with. You multiply your A term and your C term. Alright, so in this case it would be 6 and negative 35, which comes out to negative 211. Then I ask a very similar question to what I did in the first case. What are factors of that AC number that when I add them up I get my middle term? Alright, so what do I multiply to get to negative 210 that I add and get to negative 11? Well, the numbers are negative 21 and 10, right? If I take negative 21 times 10, I get my negative 211, and if I take negative 21 plus 10, I get my negative 11, and so those are the factors that work. And so what we do is, well, we take those, and that's what the middle term splits up into. So instead of having the negative 11x, I split it up into those two factors. I take negative 11 up, split it into negative 21x, and a positive 10x. And so it's the same, right? 21x, negative 21x plus 10x is exactly the same. So I'm doing a substitution step. I'm substituting out the negative 11 for these two terms. And so I get a new polynomial with 4 terms that I can solve this by grouping. So this is the answer we're going to get, but I'm going to do it by grouping. And so what we do, we group the first two terms together and the last two terms. So I'm going to group the 6x squared minus 21x grouped together, and the 10x minus 35 grouped together. And now we factor the group. So in the first group, I can pull out an x, and I can pull out a 3, right? 3 comes out of 6, and 3 comes out of 21. So I factor out a 3x. When I do that, well, I'm dividing it out, so what I'm left with, 6 6x squared divided by 3x is going to leave me with a 2x. 21x divided by 3x is going to leave me with a negative 7. Still have this plus that doesn't go anywhere yet. Alright, now I'm going to factor my second group. Well, I can pull a 5 out of the second group, right? I've got a 10 and a negative 35. A 5 comes out. When I pull the 5 out, I should be left with a 2x, right? I'm dividing it out, so 2x is left over. And 35 divided by 5 is going to leave me with a 7. The tail that I've done this right is that the two groups that are left in there should match, because that's my next step. I pull that group out. So I pull out the 2x minus 7, and then I'm left with, well, when I pull those out, I'm left with a 3x plus a 5. And there is my quadratic factored into two groups. Right? The group 2x minus 7 times the group 3x plus 5, which now I've got my two factors and I can solve. All right, so again, I can solve. Oops, that's the next problem. Give myself a little room to solve that. All right, so I'm ready to solve this. So there's my two groups where I've set them equal to 0, so that means 2x minus 7 equals 0, and 3x plus 5 equals 0. Solve each of those little equations. Right, so one answer is 7 halves, and then the second one is negative 5 thirds. Alright, so that one has two solutions, 7 halves and negative 5 thirds. I'm going to use the grouping method on the next example, which again I might give myself a little more room than I've given myself here already. Just to make sure I don't run out of space. Alright, so I already told you what it factors into, but I'm going to use the method to show you it does. So I start out with my 12x plus 5x minus 2 equals 0. First thing we do is take a times c. So 12 times negative 2, which comes out to negative 24. Alright, now I want factors of my negative 24 that add up to my middle term positive 5, right? I want to find factors, things that multiply. Negative 24 that add 5. Alright, what do I multiply to get 24? And when I add up negative 24, and I add them, I get positive 5. Well, 8 and 3, right? Positive 8 and negative 3. If I take 8 times 3, negative 3, I get negative 24. And if I take 8 minus 3, I get positive 5. And so 8 and 3 are the answers. And so what we're going to do is we're going to replace 5x with 8x minus 3x. That's what 5x is equal to. It's equal to 8x minus 3x. And so we're going to replace the middle term. So again, we're going to do a substitution step. And so this is what we're going to substitute out. So I get 12x squared plus 8x minus 3x minus 2 still equal to 0. And then I group them. Alright, so I'm going to group the first two together, the 12x plus 8x. 12x squared plus 8x separated by a plus, and I'm going to group the negative 3x minus 2. Alright, now I factor. The first group, I can factor out a 4 and an x, right? A 4 comes out of 12 and a 4 comes out of 8. So I can pull a 4 out. And remember, factor means I'm dividing it out. So I take 12 and divide it by 4. It's going to leave me with 3. I pull out one of the x's, and so I'm left with an x. Same thing with the 8x. I pull out the x, it's gone. 8 divided by 4 is going to leave me with 2. And then this kind of tells me what I want in the next term. And so what I've got here is I've got a negative on that. And so that's what I want to pull out of this. I want to pull the negative out. And so I'm going to pull a negative 1 out. When I pull a negative 1 out, then I divide out by the negative 1. And so I'm left with a positive 3x plus 2, which is what I want because I need these two groups to be the same. Alright, because the next step is I pull those groups out. I can only pull them out if they're the same. That's why I needed to factor out the negative 1 in that second group. And so now I pull out the 3x plus 2. When I pull out the 3x plus 2, I'm left with a 4x minus 1. And now I've factored, and so I've got my factors that I said we had up there. And now I set each of those to 0. So 3x plus 2 equals 0. 4x minus 1 equals 0, and solve And so one answer is negative 2/3, and then the other one, the second answer is positive 1/4. Alright, so factors into 3x plus 2 times 4x minus 1, set each of those to 0, and I solve. So one of my answers is negative 2/3, and one of my answers is positive. So again, that's where they would cross the axes. Alright, the last example here is a special case. Special type of factoring, which actually we kind of do when we were doing the group work. It's sort of just a special case. It's kind of what we were doing here, but it's if I have a quadratic, that's all I have. Alright, so this is a special type of quadratic if it doesn't have a constant term. So it's got a square term, ax squared, and it's got an x term, bx, and there's no constant there, or the constant is 0. And so when it's this special case, what you do to solve it is you factor out x. Alright, so I get x times, right, I can pull an x out of the a term, and I can pull the x out of the b term. And when I do, I'm left with x times the group ax minus b. And then those are my two factors. X is a factor, and the group ax minus b. And so I get two answers. I get one answer is always x equals 0. And then the group ax minus b is also an answer, and so I have to do a little more work to solve that. And so it always comes out to b divided by a. And that's what you always get in this case. Now we'll do the example with the actual numbers. Alright, so this is an example. I've got a square term and an x term. So the first thing we do is we factor out x. When I factor out x, I'm left with a 9x and an 11. And so one solution is x equals 0. One of my answers crosses the x-axis at 0. The other solution would be at the 9x equals 11. I've got to solve that. So again, I've moved my 11 over. I'm left with 9x equals 11 divided by 9. And so the other one is 11 ninths. So it crosses the x-axis at 0 and 11 ninths. Alright, the second one, it's a little hard to see, but it does solve down to this where I have an x term. So first thing I do, remember, always have to set it equal to 0. This is the first example where it's not set equal to 0. That's always our first step. And so I'm going to move everything over to the left side. So I'm going to subtract this 3x first. So I get x squared minus 4x plus 4 equals 4. And then I'm going to subtract the 4. And you can do that all in one step if you want to. And so what happens here is the 4's cancel. Right? So I'm left with x squared minus 4x equals 0. Now I have that form where I factor out the x. When I factor out the x, I get x minus 4 left over. And so my two answers are x equals 0 or x minus 4 equals 0. And so when I solve that, I get 4. And so the two places this graph crosses the x-axis is at 0 and 4. And so my solutions are 0 and 4. Alright, so that's a quick review of a few methods of factoring, which again, factoring quadratics is something you should be familiar with. It's a skill you should come into this class, have at least seen before, done before. Like I said, I kind of hit the big ones. If you have the box method or using a different method than I do, that's fine. Alright, but it should be similar to these. The box method is similar to the AC guess check method. And again, the other factoring methods. Alright, so that's factoring quadratics and solving using the factoring method.